This class we are going to discuss about the types of STD, syntax directed definitions. There are two types, S attributed STD and L attributed STD. What is meant by S attributed STD means in STD all the attributes are synthesized, means it is called as S attributed definitions. All attributes are synthesized, means this is called as S attributed definitions. The previous class we have seen one example, that the simple disk calculator example, that is S attributed STD. When STD is S attributed means that evaluation of attributes should be done using bottom-up parse method, and during bottom-up parsing technique the post-order traversal should be used for evaluation. And then what is meant by L attributed STD means that L attributed STDs may be synthesized or it may be inherited. But if it is anything, it may be synthesized or inherited, but the rules will be followed to evaluate the productions. So how it will be means, suppose there is a production, A defines x1, x2, etc. xn. So here this x1, x2, xn represent the non-terminals. Again that will be having a definitions. And that there is an inherited attribute xi dot a. We know that attribute will be value should be specified along with the grammar symbol, that a computed by using the rules. So we should follow that corresponding rules when we are defining that inherited attributes. So what we can in general what we can tell means S attributed STD means all the attributes are synthesized, means this S attributed STD. Then if L attributed STD means that attributes may be synthesized or it may be inherited, but when we are defining that rules, that corresponding rules should be followed for computing the associated values. Now we'll see the applications of syntax directed translation. One of the application of syntax directed SDD, syntax directed translation, is construction of syntax tree. So what is the syntax tree? We know that is the output of syntax analyzer. What is how it will be constructed? Means syntax tree are useful for representing programming language constructs like expressions and statements. So each node of a syntax tree represents a construct. The children of the node represent the meaningful components of a construct. So in a syntax tree, when we are representing the construct in the syntax tree for E equal to E defines E plus T means E will be the root. Then the plus will be represented as a root. Along with that, E and T will be added as a children, leaf node. A syntax tree node representing an expression E1 plus E2 has label plus, and that here we are having this expression will take E1 plus E2 means the plus will be labeled as a label, and that E1 is a left children, representing the sub expression E1 left children, and E2 represent the right children. So each node is implemented by objects with suitable number of fields. Each object have an that is operand field will be there, and then along with it additional fields as follows. So when any expression will take, will be having a operation to be performed. So along with that the left and right child will be there. If a node is a leaf node means an additional field holds the lexical value of the leaf. Suppose we will take a digit some value, digit dot lex value, it will take some value 3, 4, 5 some value. This is created by the function leaf of op comma value. What is the operation? What is the value should be represented? If the node is an interior node means it will be having both left children and as well as right children, and it may sometimes it may be having many children also. So in general it will be created by using the function node of op, that is represent the what operation to be performed, comma c1 comma c2 comma etc ck, c1 c2 c3 etc ck represents a children of node, corresponding node. So now we have the two types of nodes in a syntax tree. One is node, then general node will be having left children and right children, and leaf node. So it will be represented with operand value and what operation to be performed along with the value. We'll see the example now. Every time the first production E defines E1 plus T is used, its rule creates a node. So it will create, suppose we have a production E defines E1 plus T, what will be here, it will create a node, E dot node equal to new node will be created. What operation to be performed here? Plus, and what is the left child? E1 dot node, and right child is T dot node. Okay, right children. Then second production has similar thing. Similarly, second production E defines E1 minus T means E dot node, the new node will be created with that root is minus, and then left child is E1 dot node and right child is T dot node again. If you take E defines T then E dot node equal to T dot node. There is no difference in that thing. As it is, it will be assigned. So, that no node is created since E node is the same as E dot node is same as T dot node. Similarly, for this also, next T defines E within a bracket also same thing. E dot node is assigned to T dot node. Then T defines ID means here we know that ID is a terminal symbol, so it is a leaf node. So T dot node is equal to new leaf will be created. Along with that, what are this thing is there? ID comma what is the value? ID dot entry. Then same thing for T defines now. T dot node equal to leaf. This is also terminal symbol. So new leaf of num comma num dot value. What value it is going to take? So previously we have T3 star 5 means that num will take the value here 3. Num comma 3. Num comma 5 and so on. So like this way we have to construct a syntax tree. So we'll see that example now. So first, suppose for example we want to construct a syntax tree for a minus 4 plus c means first what we have to, which operation should be performed here? First with that a, that this will be, well this because the minus and plus both are in the same precedence level. So we'll go from left to right, a minus 4. So the first a will take, a is an identifier. Okay, a is an identifier. So the new leaf node will be created for a. ID comma entry for a, entry a. What is the a value? That entry a, leaf node will be created. And next what will happen? Next the number 4. For that also another new leaf node will be created. Then p new leaf of number comma what is the value it will given? 4. So that this and this will be created. Then next a minus 4. Here we are having left, then operation to be performed, and then right child. So the now new node will be created. Along with that new node, what is the operation to be performed here? Minus. Along with that minus, what is the thing that is ID is, that is first already created, it is called as P1. Then next is the 4 will be created leaf node, that is called as P2. So node of minus comma P1 comma P2, the operation to be specified within the single quote. Then next what will happen? Next 4 plus then C. Next we need C. C we have to create a leaf node. So that will be created leaf node. This is an identifier. So ID comma entry C. That will be created. Now after creating that, that will be added with this a minus 4. So now this a minus 4 is one left, that one node, left node, then C is right child. So we got to make P5 equal to new node of operation to be performed is plus. Then this a minus 4 is there in P3. Here only we made this. This is a P3. So P3 comma the C is there in P4. So this like this way we have to construct the syntax tree. So leaf node means only it will be having its the value, what is that ID, that or number, that value. Along with that it will be having the corresponding value. Then node means we know it will be having an operation to be performed along with what is the left child and what is the right child. So I think you people understood what is the application of syntax directed translation. One of the main application is syntax tree. So please try with another examples. You take some other expression example and try to construct a syntax tree. Thank you.